Here we are going to define what we mean by a polynomial function. Polynomial basically means many terms. Terms are pieces of algebraic expressions that are separated by plus and minus signs. By definition, a polynomial function must have whole number exponents. We see that this particularly ugly notation is what we mean by a polynomial function. You see the plus signs in between the terms. Those could actually be pluses or minuses. We see in front of the x's we have these a sub n's, a sub n minus 1's, and so forth. Those are going to be real numbers that we call coefficients. And then we have the x part of the expressions, the x to the n power, x to the n minus 1, and so forth. That part will be some variable raised to a whole number power. Okay, now, one important thing about polynomial functions is that for many problems, it is important for us to write them in descending order. Descending order means that you write the term that has the largest power first and then go down from there, second largest, third largest, and so forth. The leading term of a polynomial is defined to be the term with the highest power or the highest degree. The leading coefficient is the real number value that's in front of the x. So the leading coefficient would be specifically the coefficient on the term that has the highest degree. And then finally, the degree of a polynomial is the largest power that the polynomial has. Polynomials can be classified according to their degrees, and I've written down several examples here to the side. If you want to stop the video and write those examples down, that would be a good idea. The first one that we classify is what we call constant, and the degree of a constant polynomial is 0. Okay, the reason for that, I've written this example out and I've said f of x equals 7x to the 0 power. You actually never see the x to the 0 power. What you'll see instead is something like f of x equals just 7. It makes sense that we call that a constant polynomial because it's just the constant number 7. But if we did have an x with it, it would have understood power of 0, and the reason being we know x to the 0 is equal to 1, so here 7 times x to the 0 would be the same thing as 7 times 1, or just 7. The next one down we call linear. The degree of a linear polynomial is 1. So I've written an example here, f of x equals negative 2x plus 4. We see that we don't have a power on the x written, but it's understood to be a first power. Quadratic, we've studied these before, it has degree 2. And so the highest degree in that polynomial is squared. We see an example here to the side, highest power x squared. A cubic is degree 3. And I've given an example here. Notice that the actual coefficients don't have anything to do with the classification. It's only the powers on x. So like here as coefficients I have negative 1/2 and I have negative 5. Those numbers don't make any difference. The only numbers that make a difference is the actual highest power that you have on x. And then finally we have quartic. Quartic has degree 4. I've given you an example here that has highest power of 4. Also notice that you don't have to have all the powers. So in other words, on this last example I have x to the 4th, but I'm missing an x to the 3rd term. I'm also missing just an x term. It's okay if you don't have those other powers. It's just important that the highest power is to the 4th if you're talking about a quartic type polynomial. So in summary here, the most important thing as far as the problems that we're going to work is talking about making sure to write polynomials in descending order. And let me kind of show you what I'm talking about there. If I have a polynomial along these lines, let's say it's f of x equals 2x squared minus 5x to the 4th plus 3x minus 2x cubed plus 1. We see here that my powers are mixed up, and so I'm going to want to rewrite this problem highest power first, so negative 5x to the 4th. The next largest power, negative 2x to the third. The next largest power, plus 2x squared, plus 3x, plus 1. So it's in descending order. The other thing that I'll specifically talk about is the leading term, the leading coefficient, and the degree for this example that I have below. So on this example, the leading term is defined to be this entire term that you have here. So leading term would be the term that has the highest power, which in this case is 4, but you take the entire piece. The leading coefficient, and I'm going to abbreviate, the leading coefficient is the real number part off of the front of that without the x value, so in this case negative 5, and then the degree of the entire polynomial is the largest degree that you have, which in this case is degree 4.